Counting with permutations. Well, what is a permutation? A permutation is arrangement of a set in a particular order. So the big key here is that order matters. When you're reading a problem and you're like, yeah, it matters who comes first, second, or third. That means you're dealing with a permutation. So I always think about finishing at the Olympics. Does the order matter? Does it matter who finishes first compared to second? Yes, because if you're first, you win gold. If you're second, you win silver. If you're third, you win a bronze. And if you're anything below that, you get nothing, right? Your name is in a book that you were at the Olympics, and that's about it. But the order does matter. So let's say 3 people are competing for the top 3 spots. How many ways can that happen? Well, if we have 3 people in 3 spots, then we'd say, well, 3 people have the possibility of getting that first spot. And then one of them does. So there are 2 people left to battle for the second spot, and then whoever is left gets the third spot, which means there are 6 different ways that we could have the top spots. When you multiply in order like this down to 1, this is called a factorial. Okay, so 3 times 2 times 1 is a factorial. Let's do another one like this. There are 8 horses running a race. How many ways can they finish? Well, again, there are 8 possible horses for the first spot. And then after that horse crosses the finish line, there are 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. Now, your calculator might have a button that's an exclamation point. That's the same thing. 8 factorial means exactly this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320. So if we have 8 horses in a race, there are 40,320 different ways that they can finish 1 through 8, like distinct ways. Isn't that crazy? So many. Okay, now that's factorial is when we are counting all of the ways, right? We have 8 horses. We care about all 8 places, but we don't always care about all the places, right? Let's go back to the Olympics. We have 12 swimmers in the finals at the Olympics. How many top 3 finishers could we see? Since generally we have a gold, silver, and bronze, I know sometimes there's ties, but gold, silver, bronze. We only care about the top 3 finishers, and the order matters. So we do what we call a permutation, and we would say 12P3, and you're like, I'm sorry, what? Okay, let's talk about that. If not all of the items are included, we use something called a permutation, NPR. Now, N is the total possible people that are involved in this. How many totals can we pick from? And then R is how many do we care about ordering, right? How many do we actually care about? So that might sound harsh, but it is what it is. So you can see we have 12 total swimmers. So the N in this case is 12. The R is 3 because we want to say the top 3 finishers. Those are the ones that we are ordering, just the top 3. Now, what this means is, let me find where's my notes here. So NPR is, we find that by taking N factorial over N minus R factorial. And you might say, oh my gosh, this is looking hard, but just bear with me for a second here. When we go back to our example and we say, okay, so I'm looking at N factorial over N minus R factorial. So my N is 12. So I have 12 factorial over 12 minus 3 factorial. Okay, well, let's just simplify that 12 minus 3, and that's 9 factorial. So let's look at what this means. This means 12 times 11 times 10 times 9 times 8 times 7, and goes on down to 1. And 9 factorial means 9 times 8 times 7 times 6, and it goes down all the way to 1. Well, 9 down to 1 cancels out with now 9 down to 1, and I'm just left with 12 times 11 times 10. So you'll notice that the relationship between what I end with here, 12 times 11 times 10, and what I started with, well, I start with 12 factorial, but I only use 3 numbers, 12 times 11 times 10, and it'll always work like that. So 12 times 11 times 10 gives me 1,320. So there are 1,320 different ways that we could finish these swimmers in order here. Okay, so let's do another one. There are 9 people on a committee and 2 need to attend a fundraiser. The first person selected must give a speech. Ugh. How many 2-person combos could we have? Okay, so the order matters because the first one's going to give a speech. So we have 9p2. So that means 9 factorial over 9 minus 2 factorial, which is 9 factorial over 7 factorial. So again, this is 9 times 8 times 7 times 6 all the way down to 1. And 7 times 6 times 5 all the way down to 1. So these cancel out with these, and I'm just left with 9 times 8. Start with 9, 2 numbers. 9 times 8 is 72. So there are 72 different 2-person combos we could have based off this committee of 9. And that's the idea of permutations and using that formula.